Now, let's talk about the spin orbit interaction in an atom. And certainly, uh, angular momentum is linked very much magnetically. Now, what we have is we have an electron and we have a system of electron and nucleus. And if we seek the fine structure, and what we find is that we have doublets. If we see it in a very high resolving power microscope, and these doublets, they basically arise from magnetic interaction. Now here what we have spin orbit interaction, spin and orbit interaction, and this doubling is a result of spin orbit coupling. We call it coupling. There's interaction between spin of an electron and the orbital motion. Now, spin orbit coupling, we can understand it in terms of classical model, if we take into account the classical model. And what it says that we have an electron, and this electron is revolving about the nucleus. We have a nucleus and we have an electron revolving, and finds itself in a magnetic field because in its own frame of reference where the electron is. And the nucleus is circling about it. The nucleus is circling with respect to with respect to the electron, and this magnetic field then acts upon the electron's own spin. This nucleus appears to be moving to the electron, and showing it at some point, and this is an electron, right? And if we assume that the direction is like this, now what's happening for the electron? The nucleus is also moving. It's also moving. So this magnetic field then acts upon the electron's own magnetic moment to produce a kind of some kind of Zeeman effect that we have, splitting of the spectral lines. And what am I trying to tell here is that we have an electron, and this electron is circling the nucleus of this atom, and as viewed from the frame of reference of the nucleus, it's rotating. Now, from electron's point of view, the nucleus is circling it, and the magnetic field the electron experiences as a result is directed upwards. The magnetic field is directed upwards from the plane of this orbit that we have assumed here. And the interaction between electrons' spin magnetic moment and its magnetic field that it has, it leads to the phenomenon of spin orbit interaction, what we call as spin orbit interaction. And the potential energy, suppose that is um, and the potential energy of a magnetic dipole that we have, of dipole moment, say mu, in the magnetic field of B can be written as minus mu B cos theta. This will give us the potential energy. And the theta that we have here, this is the angle between the magnetic moment and the magnetic field. And the quantity that this mu cos theta, basically it is a component of mu, the vector mu, parallel to the magnetic field. And in case of the spin, in case of the spin magnetic moment of the electron, this component is taken as, if you rightly remember, as mu s z, and that is plus minus mu Bohr magneton. I don't know whether it's viewable in my phone, but I hope it is viewable. And so what can we say is that this mu cos theta is plus minus mu b. And the spin orbit coupling that is there is the energy involved, that is plus minus mu b and p, taken out the cosine component. Now, depending on the orientation of the spin vector, okay, the energy of an atomic electron will be higher or lower by the amount mu b, depending on the orientation of the spin. And its energy without and the energy that will be involved here. The result is that every quantum state except the s quantum state, the s orbital, in which there is no orbital angular momentum, splits into two substates. So s is not going to split, but other orbitals other than that of s, they are going to split into two substates. And for s equal to 1 by 2 is the only one that agrees with the fine structure doubling. This is the value for which this doubling agrees, the doubling that we have. This is because what would be single state without spin are in fact twin states. The 2s plus 1 states that we are talking about. And these are the possible orientations of the spin vector s. And this s must be total equal to 2 times 1 by 2 plus 1, that's equal to 2. And with this 2s plus 1 equal to 2, the result is 1 by 2. So this is what leads to spin-orbit interaction, the splitting of energy levels due to spin-orbit interaction.